Have you ever given this a wild thought? Falling into a black hole in space? Black holes are the most notorious space phenomena around, besides aliens, whose existence is still debated. Many people are familiar with them from movies and other pop culture references, but few of us outside the realm of astrophysics know what they truly are. The following video is an exploration of these wonders of the cosmos. We look at the 101 about black holes, how they are formed, and their crazy abilities. Even more importantly, we'll look at what would happen if objects, or people, happen to fall in one. With that, saddle up, buckle up, and prepare for takeoff. Famed German physicist Albert Einstein, who dedicated his life to the concept of relativity, changed the world with his ideas. Firstly, he claimed that objects moving at certain speeds in straight lines may interact differently with space and time. This is special relativity. For example, a puppy in a spaceship moving at the speed of light would age much more slowly than its litter mates back on Earth, an occurrence called time dilation. After a while, the space-traveling pup may be noticeably smaller than its siblings, a phenomenon called the twin paradox. In 1915, Einstein followed this up with the theory of general relativity. This states that gravity is a force that can bend space. Additionally, the greater an object's mass, the greater its gravity, and, ultimately, the more it can bend space. For example, let's say you were to place a brick in the middle of a trampoline. The mass of the brick would cause the trampoline's surface, aka space, to bend. Objects on the trampoline lighter than the brick would roll, or gravitate, towards the middle. The same principle applies to the Sun, which is heavy enough to bend space in our solar system and pull planets toward itself. Interestingly, the bending of space also causes time dilations. In other words, the greater the gravity, the slower time moves. Anyone who has seen the movie Interstellar would be familiar with this. Based on these theories, Einstein's calculations led him to conclude that objects much heavier and denser than our own Sun and planet could have a much greater impact on space-time. Little did he know it, but he had just stumbled on the theory of black holes. How are black holes formed? Following Einstein's theories, numerous physicists ran with, built upon, and countered his equations in the 20th century. It was eventually established that at a sufficient mass, objects could rip holes in the universe itself. These holes can absorb matter, light, and time. In the 60s, American astronomer and physicist John Wheeler coined the term black hole to describe these anomalies. A black hole is best described as a trapdoor, where space and time simply cease to exist. Science is yet to establish a way of analyzing a black hole's internal workings because it is impossible for people or probes to go into one and report back. What we know for sure is that black holes have at least three properties: their mass, spin, and electric charge. Black holes are formed in at least two ways. The most common means of formation is the death of very large stars. These stars, which are at least 20 times larger than the Sun, eventually run out of the hydrogen that fuels them. When this happens, they implode under their own gravity and leave behind a much more compact and dense object. This object, or stellar mass black hole, gains even greater gravitational pull than the star that preceded it. The other way black holes form is when two or more stellar mass black holes merge. This can happen in especially crowded galaxies. These anomalies are known as intermediate mass black holes and can be between 100 and 1,000 solar masses. Then, we also have supermassive black holes. Theories about how these are formed vary, but the most common one involves a runaway chain reaction of star and black hole collisions. Essentially, an intermediate mass black hole that has run amok and swallowed up nearby stars and black holes. Supermassive black holes are at least 100,000 times heavier than our Sun and up to several billion times heavier or more. What happens to objects that approach black holes? To the human eye, a black hole just looks like nothing, a void of total blackness that doesn't reflect or project any light. This means that against the black backdrop of outer space, black holes are invisible. The only way to see a black hole is if its effects on nearby light and matter are visible. In other words, if it is bending light and matter towards or around itself. The immediate space around a black hole forms an invisible shell known as an event horizon. Anything that passes into the event horizon, including light, disappears into the black void. Much like the Sun or planets, black holes also exert enough gravity for objects and light to orbit them. Most depictions of black holes show them surrounded by warped rings of light and matter like space rocks and dust particles. These orbiters, collectively known as accretion disks, rotate around the black hole at extraordinary speeds. Depending on the size of the black hole in question, matter in accretion disks can move at nearly half the speed of light. At such speeds, objects may bump into each other, causing friction, heating, and illumination. So interestingly, the region outside a black hole's event horizon shines extremely bright. As you can see, a black hole can warp matter and even light itself. But did you know that they can also warp reality as we know it? For starters, if you were to approach the inner parts of the accretion disk just outside the event horizon, you would see yourself. Well, more like an image of yourself looking at the black hole from behind. This trippy Hall of Mirrors phenomenon is possible because the light behind you would orbit around the black hole and reach your eyes again, allowing you to see yourself. Confused? You're not alone. Another rule of reality black holes love to break is that of time. Before Einstein's theories, we thought time ticked along the same everywhere in the universe. But time is, in fact, relative depending on factors like speed and gravity. If you were to be near a black hole with greater gravitational pull than Earth, time would move considerably slower for you. This time, dilation could be so extreme that half an hour near the black hole equals several decades on Earth. Your kids may be older than you by the time you return to Earth. Or worse, everyone you knew may have been long gone, with the world now filled with flying cars and robot overlords. This crazy time dilation may hold the key to time travel, at least into the future. That said, getting too close to a black hole is probably the last thing anyone would ever do. The extreme gravity would simply pull you into the flaming accretion disk, which is made up of rapidly flying and burning matter. If you could somehow get past the accretion disk, the extreme gravity would pull you so hard you would stretch and thin out in a process known as spaghettification. Essentially, the black hole would slurp you into a tiny core known as a singularity, a super compact package of all matter that has crossed the black hole's event horizon. It would be unimaginably painful, but at least it would be quick. On that scary note, it's time to end. Thank you for watching and do subscribe to help the channel grow. Also, like the video for the algo and comment on any other topics you want us to cover. Thanks again and goodbye.